So thanks everyone for joining eTruck's Technical Advisory Committee, last one of the year. Thank you all for being here today, and let's get started. So next slide. So this is the team we have here today. We have Watson Collins, Senior Technical Executive with EPRI, Ken Lim, Technical Leader, Electric Transportation with EPRI, Yazan Tomic, Vice President with CalStart, myself, Nate Fernandez, Technical Program Manager with CalStart, Michael Joseph, Program Manager with CalStart, and Liz Hellier, Project Manager 2 with CalStart. And who we have here as part of our committee are federal agencies like Department of Energy, Federal Highway Administration, EPA, US DOT, and then ports. That's Port of Los Angeles, Port of Long Beach, Port of Oakland, and Port of San Diego, and utilities, PG&E, LADWP, and SCE, and then state agencies like CEC, BARB, CPUC, SCAG, and Oregon DOT. And then for associations, air districts, and national labs, we have NATSO, NACFE, AQMD, Sacramento Metro Air Pollution Control District, and Argonne National Lab. Thanks to everyone here for joining. So for our agenda today, I'll go through a quick project overview, remind everyone what we're aiming to achieve with the eTruck program, and then go through some quick project updates. Had a lot happen in 2024, so want to recap the highlights for you all. And then we'll move on to our workforce development mapping tool, and then our main discussion topic, which is planning for phase 2 of the eTruck project. And then we'll close it out with next steps and closing items. Okay, so eTruck is the Electric Truck Research and Utilization Center. The purpose is really to create a high power charging infrastructure hub, research hub along key freight corridors, and to accelerate the electrification of the heavy duty vehicle market. And our work can be broken out into these 4 different categories, like equity and workforce development, which we'll be reviewing our workforce development mapping tool with you all today. And then we have some community-based organizations that are getting feedback and doing community engagement for the project. And then for market needs and technology assessment, we're assessing the technology readiness of all these different stakeholder groups, so truck fleets, charging equipment and service providers, and then outreach to manufacturers, utilities, planning agencies, and putting all those learnings and all that feedback into some reports that we'll review in a few slides. And then for research and development, that includes our activities such as the Advanced Transportation Research Center, which will provide some updates about that today, and then also our pilot deployment sites, one near the ports and then one near the distribution centers in Ontario. And lastly, the public corridor charging strategy segment, which is really to plan, design, and deploy innovative and skilled charging strategies for heavy-duty electric trucks along priority corridors. Next slide. And just a quick reminder of the goals and the purpose for this technical advisory committee. The goal is really to provide overall project direction, and we use your feedback to review our deliverables and our work that's really aligned with the overall project purpose. So your questions, your suggestions, any related work that you have going on that's aligning with what we're doing, it's all very much appreciated here. Next slide. think that is it. With that, I'll pass it over to Liz to go over project updates and our 2024 recap.
Thanks, Nate. Liz Hellier here, project manager on the Clean Fuels and Infrastructure team at CalStarts. Just wanted to give you the opportunity to put a face to the voice, but I've been having connectivity issues, so I'm going to turn my camera off just in case. All right, so as this is the last TAC meeting of the year, we wanted to highlight some of the kind of key milestones of 2024 for the eTruck project. So first off, 2024 really was marked by a focus on leveraging industry expertise and feedback through our 4 external advisory committees that we host as part of the eTruck project. So the first one being the TAC, this one being the third of the year, but also through our quarterly ITAC, which is Industry Technical Advisory Committee. And so in this one, we're able to leverage stakeholder expertise from infrastructure developers, original equipment manufacturers, truck operators, utilities, and ports. We also host the CTAC, the Community Technical Advisory Committee, in which we can leverage expertise from our CBOs that we work with, so that's community-based organizations, academia, focused on kind of equity, and also through our quarterly WEDAC advisory committee meeting, so that's workforce development advisory committees, which also has kind of training centers, academia, and community-based organizations as well. And so, for example, for the eTruck project team gained insights from, on the one hand, utilities through our guest panelists through the ITAC, and on the other, we also hosted a panel of infrastructure developers to gain insight on grid connection timelines, interim solutions, and also taking a proactive approach to grid upgrades. Another example of how we've leveraged expertise in 2024 is through the participation of selected community-based organizations in the WEDAC and CTAC, and kind of allowing the team to gain insights on what equity metrics are important to the communities. And so I do want to pause here just to kind of highlight that we have an incredible opportunity through the eTruck project to kind of leverage expertise from very distinct focus groups here. And so if, maybe we can open the floor here and ask TAC members if there was a particular subject that really kind of you found was very important in kind of the overall goals of the eTruck project, or if there are specific topics that you would be interested in hearing more about through one of our advisory committees in 2025. I'm just going to pause here and open the floor. And that's fine. Also, feel free to email the team if you have any topics that may come up as an interest to your particular organization. And John, I see your hand raised.
Yeah, hello, Elizabeth. This is John McKillen at EPA. Can you hear me?
Yes.
Hey, everybody. Just on this topic of streamlining stakeholder processes for utility upgrades, I think that's a really salient and timely issue. It's one that we're actively encountering, particularly in California, for truck electrification projects. So I think that's one certainly worthy of attention by your group. And I'm sure EPRI has a lot of resources going into this as well. I had a huddle with Dan Bowermaster and some others at EPRI on this topic about interim solutions to grid interconnection for EVSE a few weeks ago. And so I don't know if you've gleaned any learnings or solutions in that regard, but it's certainly one where we're seeing a lot of suboptimal solutions being implemented by fleets to circumnavigate delays in grid interconnection for EVSE for high power, either depot charging or for controlled access plaza charging. So I'm just wondering if you guys have gleaned any kind of pathways to resolution, or if that's still a work in progress. But moving forward, I think that continues to be a high value target for this organization. So just my 2 cents on the topics listed here.
Thank you, John. Maybe I can open the floor up to either Ken or Watson on the EPRI team to give insights on the grid interconnection topic.
No, really couldn't agree with you more about that. And I think we'll talk a little bit more about that in the phase two part, because I think we're gonna aim at that set of topics that you're pointing at for the phase two part of this project.
Stacy, I see your hand raised.
Yeah, hi everyone. Stacy Simmons with CalSTART. I'm the senior director of this Clean Fuels and Infrastructure team. I just want to second to the second that this is a really important topic. And last year we did engage with two specific activities. One was the energization roundtable, where we had about four, and there are folks from these organizations here that participated, but we did a series of workshops really focusing on energization timelines. Out of that, we did a 2-day workshop with SDG&E where we broke down their application process and worked hand in hand with some of the industry members to actually go through and show how the industry responds and what they are providing in application, how it may or may not serve the needs for the utilities. And I think from it, we gleaned a handful of really good ideas that are being reviewed and being considered now. So as we're moving forward on the topic, making sure that, we're going to be sharing all of the things that we can through the white paper on the energization roundtable workshops, and then also the outcomes from this. I think that participation in that coordination and workshopping between utilities and our different groups is going to be really important. I think it's a good opportunity for us in 2025 to continue to lean in on it. So just want to second it and then mention two of the things that we were working on. So thanks for the floor there for a second, Nate.
Thanks, Stacy.
Thanks, everyone. Maybe we can move on to the next slide, please. Thanks, Chia. So as you can see, the eTruck team has been very busy in 2024, developing and publishing some key reports and maps as part of the eTruck project. So maybe to give you an overview of what this body of work represents in terms of kind of efforts through the eTruck project here. So the project team focused on the one hand on assessing technology maturity of high power charging, on the other assessing fleet charging infrastructure needs through a series of surveys and interviews, and also on the other hand monitoring current medium and heavy duty public infrastructure deployment in California. And so the combination of these efforts helped the team gain an overview of where high power infrastructure is currently at and where the industry needs to be on the first hand by 2030, 2035, and 2040 to meet these infrastructure needs that we've identified through this body of work. So I'm just going to maybe also add the link to these reports in the chat here, but these are also kind of going to be available once we share the slides here. You'll be able to click on the various links. I do want to highlight one key deliverable here on this slide, which is the number 4, fleet charging infrastructure needs and technology maturity assessment, which really is a summary of all of the kind of interviews, surveys, data, and findings of the eTruck project, and kind of also offers an analysis component of all of these different data sources and kind of recommendations for the eTruck project moving forward. Thanks, Chia. Moving on to the next slide. Just giving you here a quick overview of the project progress in terms of modeling medium and heavy duty charging infrastructure needs as part of the eTruck project. Again, we've met some key milestones here for these efforts. The first one here being collecting data and feedback from the freight industry, from original equipment manufacturers, EVSEs, and kind of really understanding some of the key assumptions that are being fed into modeling charging needs through the Lawrence Berkeley National Lab heavy load model. Excuse me. So this is one of the kind of the highlighted reports there mentioned on the previous slide. And secondly, we've also worked with Cambridge Systematics to really understand freight travel patterns by truck market segment. So here we're looking at drayage, regional, and long haul, and understanding for each market segment the routes, dwell times, and hours of operations. Again, which will be feeding into the heavy load modeling charging needs. Which brings us to kind of what we are in the midst of kind of developing at this point in time, right? Q4 2024, which is integrating all of these assumptions and travel demand data that we've kind of collected and built throughout 2024 into modeling charging needs in California. So you may have seen the heavy load model results through the CEC's AB 2127 previously. So by integrating this new data, the team is able to take this model a step further. So we're now looking at modeling charging needs by market segment, right, with industry-specific charging behaviors. For drayage, for example, versus long haul, we're seeing very different charging patterns there. We're also now able to model route planning as opposed to single trip planning, right? So we kind of have an overview of a day of one singular truck and how many trips that this truck is making throughout the day, and when would be the ideal times for this truck to charge. And we're also modeling the charging needs at a more granular level. So we're going from county level to looking at more site-specific levels. At this point in time, looking at a 2 to 10 mile radius. And so this now brings us to kind of the key milestones to look forward to in 2025. So kind of leveraging all of this information, presenting the modeling needs through what we're calling HEMAP 2.0, and then taking the modeling needs a step further, which will be HEMAP 3.0, which really is kind of a planning map where we start analyzing the results that we're seeing through the modeling and kind of making key recommendations through the final statewide infrastructure plan, which will be coming out in Q3 2025. Again, I'm happy to pause here if anyone has any questions regarding the modeling efforts. John, I see your hand up.
Yeah, just on the site prioritization framework, can you talk a little bit more about the metrics that you guys are using for site prioritization in terms of, the data sources and also the metrics that you're using to evaluate which make the most sense for near term versus medium versus long term prioritization for EVSE site development?
Absolutely. So the site prioritization framework is a collaborative effort with SCAG, Cambridge Systematics, and ICF, and also kind of leveraging kind of the feedback from our community technical advisory committee for the equity metrics, for example. So we're looking at, on the one hand, kind of truck volumes and utilization at a kind of particular spot, but also grid upgrades needed at that location. We're also looking at specific equity metrics, so making sure that for example, communities that are experiencing at this point in time the negative effects of diesel are also, by having the station nearby, for example, able to also leverage the positive effects. And I'm also happy to send you, John. It was one of the presentations that we did in our industry technical advisory committee. So I'm happy to share the results and the feedback from that.
Yeah, thanks, Elizabeth. In particular, I'm interested in the grid upgrade layer and kind of what sources you're looking at there in terms of feeder capacity and needs for transformer and or substation upgrades in or around the site as defined. That's really been kind of one of those key areas of go, no go decision making for some of the projects we've tried to entertain in partnership with industry.
Got it. Thank you, John. Catherine, I see your hand up.
Yes, good morning. I'm Catherine Garrison, the California Air Resources Board. It's very exciting to know about the travel demand model using the routes and dwell times. And it's also mentioned on the slide here about the travel patterns. And so I was curious if you might be able to dig a little bit into what information was used for the trip origin and destination data.
Absolutely. So the kind of base data there is INRIX data, so kind of truck GPS tracking that has been expanded to represent kind of California. And then we've been able to identify through this truck GPS data, based on also the origin destination, whether the truck is considered regional delivery trucks, for example, versus long haul trucks versus trucks that are stopping at certain ports and are considered drayage. Again, I'm happy to send you, Catherine. We have a technical memo kind of going into the sources of the travel demand model that I can send.
Yes, yes, that would be wonderful. And then I was wondering if you were able to determine if if the trucks are your temperature controlled, like if they have a transport refrigeration unit on them in this GPS information.
I don't believe so. But again, I just want to definitely double check in the technical memo, but not from my understanding.
Okay, thank you. Great work.
And Liz, could you also talk a little bit about how this is coordinated with the CEC and their other modeling activities?
Absolutely. So we're also working with, at this point in time, with the CC team working on the AB 2127 assessment, which kind of is being wrapped up by the end of this year. And so they are also using the heavy load model kind of developed by the Lawrence Berkeley National Lab, which is what we're using for the e-truck project. The e-truck project has a little bit more flexibility as it's more of a research project. So we're able, for example, to change some of the base assumptions going into the modeling, and also kind of looking at individual load shapes for specific locations. And so we're just kind of working with that team to make sure that the data, first of all, aligns in terms of the overall charger needs in California, but then also able to kind of present this on a more granular level, as opposed to kind of county level, as has been presented previously in the AB 2127 assessment. Thanks, Jonathan, for answering that question. Oh, sorry, I think that was a direct message, Jonathan. Thank you.
No, sorry, fix that. There you go.
Great. If there's no further questions on this side, I'll pass it on to Ken.
Thanks, Liz. So updates on the two demonstration sites for eTruck. To summarize the update for both sites, the focus for this year was primarily on engineering designs, construction documents, and equipment selection, procurement, and permitting. So starting with the first site, which is the existing travel center's location in Ontario, we selected a vendor for a megawatt charger prototype for this site. This site also has a microgrid consisting of a solar canopy and energy storage system. So this past, so throughout 2024, we worked through the engineering design, product selection process, and submitted for permits with the AHJ, City of Ontario. And the forecasted permit ready to issue date based on our initial first round of review comments and so forth is projected for end of this month, with plans to mobilize and begin construction in Q1 of 2025 for the travel center's location. So a lot of good progress going on. A lot of great work with our partners over at TA and BP. In terms of the actual go live date, we are still coordinating with the utility on getting a more accurate energization date at this time. So right now we're forecasting the third quarter of 2025 for project completion and go live, with the hopes that we may be able to pull this in as we work through and do this coordination with SCE. In terms of the second site here, which is MHX, this is it's a drayage focus MHX warehouse where we are adding 4 CCS chargers and energy storage system to their site. Similar updates, right? So engineering design is nearing completion at this time. We have the equipment vendors identified. All the procurement is underway. The permit submittal we're planning to submit for end of this month. So similar to the TA site, where our plans are for the MHX site to move forward with construction in Q1 of 2025 with a forecasted infrastructure completion date of Q2. But again, coordination with utility for energization. So right now, similar to the other site, we're forecasting both of them to be live in Q3, with hopes that as we coordinate and have discussions with SCE, we may be able to pull that in. Yeah, that's the latest updates and plans for 2025 for the demonstration sites. I'll pause here to see if there's any questions or comments. Yes, John.
Hey, Ken, thanks for the updates. So in terms of peak load for these 2 sites, for the 4 CCS chargers, what do you anticipate the kind of peak demand once they're all up and running would be at that site versus the megawatt charging at travel centers? Do you expect that the load would be similar, that the 4 CCS would be lower? Because if they're 350 kW or higher CCS, the potential for all 4 of them to equal the load profile of 1 megawatt charger is possible. So I'm just trying to get a sense in terms of the interconnection element for these 2 sites, if they're similar from a grid perspective.
I think from a theoretical peak demand, you're right in that it may be similar if we're looking at the 4 CCS chargers versus the 2 megawatt chargers. But I think from an operational standpoint, the way the sites were designed, the realistic peak demand is going to be a lot less on the drayage location, just because the way they schedule their vehicles is for shorter vehicle charges. So as the trucks come in and they're loading and unloading for a 15 to 30-minute time frame, that's when they're really going to be charging. And the trucks' acceptance rates themselves are actually going to be no more than 200 kilowatts, I believe. So I don't know if that answered your question, but how we determined peak demand was pretty much from looking at the types of trucks that would be utilized or the charging schedule that MHX is able to implement for their location, and then also utilizing or leveraging energy storage to sort of offset peak times as well.
So, and John, I think the crux of your question gets a little bit at this flexible interconnection question, kind of because the MHX site, while the chargers have a power rating of 350 kW, the trucks that are going to charge there cannot receive 350 kW charging. So the majority, so the reality is that while there may be a few trucks that charge at that power level, the vast majority of the trucks are going to be charging at a lower power level than that. As comparison to the near megawatt charger at the chargers at the TA site, which those trucks will be matched with that charge there with the power level of the infrastructure. So it's more likely in the short term that that there'll be a matching of the power levels and a full utilization of the power level of the infrastructure at the TA site earlier than the full power utilization of the charging infrastructure at the MHX site out of the box.
Thanks, Watson. That's exactly what I was wondering. Thank you for getting at that extra layer.
Perfect. Any other questions? Can we go to the next slide, please? So updates on the Advanced Transportation Research Center. So in collaboration with SCE, as part of the eTruck project, we're putting together a lab, and the purpose of this lab is to advance the high-powered charging technologies, provide a place for the industry to test interoperability, test power quality, test any sort of testing for the EVSCs, whether it's a prototype or an EVSC that's already in production. The point is to help the industry improve in terms of reliability or do some behind the fence testing before deployments, or advance future technologies as well. So with the past year, we've successfully received all of our test equipment from Keysight. We were able to install and commission what we're calling Phase A of the Advanced Transportation Research Center, which has a limited power capability of 350 kilowatts of testing. We also have our first applicant in the pipeline right now that's moving through the contracting phase to bring their equipment to test at this lab. So in terms of next steps for 2025 for what we're calling Phase B, our plan is to work with SCE on the build out of a much larger test pad with much larger capabilities. So essentially, we're going to take all this equipment from the Keysight test equipment. We're going to relocate it into a containerized solution and relocate it outside to another portion of the property that SE is calling the high powered charging lab, that has access to medium voltage and 480 volts and 2 megawatts of direct grid capability, as well as energy storage capabilities as well. And for this Phase B portion, which we're calling the sort of the high powered charging lab portion of the project, we're forecasting to be able to move all this equipment, have it reinstalled, and have this high power capability at the end of Q1 in 2025. So again, a lot of great updates happening with the Advanced Transportation Research Center and the lab that's being built out. This lab is located in Pomona, and we have a web page on here as well on the eTruck website that Lisa just put into the chat that has all kinds of great information here on how to access the lab, how to apply, and we encourage EVSE vendors, EV vendors as well as EVSE vendors to check it out and do whatever testing needs is necessary with the lab. Any questions here? Hey, Peter.
Hey, Ken. Yeah, so the CC had a recent pre-solicitation workshop on this concept called Charge Yard. So it's intended to be an open, neutral industry facility that the CC funds that can support charging interoperability testing and kind of the furthering of standards related to EV charging. And I think that the ATRC can fulfill kind of a similar role. But can you speak to kind of the specific interoperability, conformance testing capabilities that's envisioned for the ATRC, and maybe also talk a bit about the application process. So what happens when someone applies, what kind of steps they go through before they actually start testing their technology there.
Yeah, that sounds good. I'll start with sort of the application process first. So the application runs through the eTruck website in the link that Lisa provided. There's an application form on there that the applicant would fill out that gets emailed to myself and then reviewed internally. From there, if the proposed testing and the equipment and sort of the every box is checked on the application. We move forward with a more technical review and meeting with the applicant to move into next steps. And the next steps there is essentially going through the contracting agreement phases for getting access into the lab, and that's all directly through SCE. And then things like scheduling also runs through SCE as well. And from the so the scheduling coordination application process, I would say it's more on a case by case basis, depending on the length of testing requested and so forth. And then once testing is complete in terms of the eTruck reporting efforts, the idea is that for the eTruck reporting, any sort of testing that's done in the lab, there's going to be some sort of voluntary high level information received or requested from the applicant to summarize, the type of testing done, but we wouldn't request any sort of proprietary information or data that's confidential. It's more so just an understanding of what type of equipment was tested, what type of tests were ran, and whatever level of information the applicant is comfortable providing in terms of their experience with the lab and the feedback from the lab. Is what we'd be reporting back out as part of our efforts for the eTruck project. And I don't know if I was very clear on the whole application process there, but there's a 5-step process, I believe that's listed in the eTruck website that goes into a little bit more detail. And let me see, Jordan, was there anything I missed in terms of the application process?
That's at high level. Yeah, that kind of covers it. But yeah, Peter, let us know if there's any specifics, or we can get with you offline, sometime if you want to dive into more kind of specific details. But yeah, I guess we started this concept. Maybe even claim we kind of invented this concept with eTruck, with the open access lab, and happy to have possibly inspired, which I think you're getting at, which is the overall objectives, which is to advance interoperability, cybersecurity, standards compliance, standards understanding, implementation of standards, as well as sort of verification of performance, which is important. And this, particularly with the higher power levels, which we're able to get upwards of 2.5 megawatts direct from the grid at medium voltage. That's not easily accessible in many cases, even with people that make chargers. So that was the idea here. But it did take some effort to set up this process, as Ken was going through, particularly the contracts. And so, yeah, we're running through, we've had several applicants we're running through kind of first phase of going through the contract now. So learning a lot.
Yeah, and in terms of your first question, Peter, so in terms of the actual equipment that we have on there, it's what we got from Keysight, essentially some DC emulators, AC emulators, and their charging discovery system. And it can run a whole gamut of test cases for the EV and EVSC side testing. I think some of the high level, you know, just looking from a high level perspective, we're working on a document to kind of summarize the capabilities because it really does um, have so much capabilities, it can almost create some sort of confusion on what the focus should be for testing. Um, but right now, the way we're looking at it is we're focusing on communications, interoperability, um, conformance. So there's a whole test suite for ISO 15118, DIN 70122. So without going into, I guess, into the minutia of things, um, I would just say that it includes all the communication interoperability and power quality test cases to test EVSC and EVs as well. So with that said, I guess I would just encourage the folks here that are interested to check out the website for more information there. And then coming up soon, we're also going to be publishing, like I said, a document that sort of better summarizes all the sort of test cases and the way to set up the equipment in order to do different types of testing as well at this location.
Yeah, and for folks, kind of not familiar with this equipment, which is it's a state of the art EV charging test equipment. You can get in and see exactly what's going on with the communications between the vehicle and the charger, and you can see exactly what's happening and compare with what, for example, what a charger is supposed to be doing when it receives a particular signal, or what it's supposed to be doing in sequence, and you can see exactly the real time, and you can determine whether charger or vehicle is or is not kind of doing what it's supposed to be doing according to the standard. And so you can diagnose pretty much any issue, at least know where where an issue is residing, and what should be done next. And then that's sort of one category, but it also gets into, as Ken is indicating, just performance metrics on what the system imposes upon the grid, and that type of thing. So it allows you basically to do not only full diagnosis, but also characterization.
Thanks, Jordan. I think Jonathan, was your hand up? Did you have a question for us?
Yeah, it was somewhat answered by some of the conversation, but Ken, when you mentioned that the equipment was sort of containerized and moved on site, I was interested in understanding if this was a way that sort of short-term charging locations could be stood up with sort of like this modular approach. But it sounds like the containerization was more of like a kind of one-off, kind of like portable lab for testing equipment.
That's right.
We do have interest from some folks who have leased sites that do have, a decent amount of power that could maybe support one or two chargers, but they're maybe not necessarily interested in sort of fully standing up and making permanent installations. There may be some kind of real estate concerns or something like that, but they would be interested in potentially leasing their land if they could get a sort of temporary charging station set up. We see similar things with kind of hydrogen where it's trucked in, and there's just kind of like a little stand where someone's filling up trucks as they come through. But so again, sounds like this is more of like a one-off lab and not a kind of all-in-one modular solution that could sort of scale. So,
Yeah, no, that's right. It's more so the former of what you mentioned.
okay, thanks.
And then Ken, we have a question from Stacy in the chat, but I think in the interest of time, maybe just answer it in the chat.
I'll respond in the chat. I know we're over time here. Sorry about that.
All good.
Maybe if we just move on to the next section, and if there's any additional questions on the lab, feel free to just email myself, and I can provide some additional documentation and responses as well on the lab. So in terms of timelines for where we're at now and 2025, so we're working through the modeling results that Liz had mentioned earlier for the SCAG region, and we're hoping to expand that out for the statewide region in Q1 of 2025. There's going to be a build out of a workforce development tool in Q1 2025 as well. And then heat map 2.0, which is going to add into the existing heat map 1.0 and add in pretty much a heat map showing charging needs, regional charging needs across the state of California. There's going to be the ATRC lab opening that we discussed in the previous slide. And then moving into Q2, there is a BEV infrastructure toolkit and a guidebook to advance BEV charging. And this is really just a summary of key learnings, lessons learned, best practices, FAQs, and so forth to take from what we learned from eTruck and what we've gathered and put this together into a couple deliverables for the industry. And then we also have a high power charging equipment R&D report, which is a summary of the utilization and the equipment tested in the ATRC. And then, of course, the site opening go live dates, which we mentioned earlier in Q3 of 25. And then wrapping up Q4 of 2025, there's going to be a third iteration of the heat map that just adds additional capabilities to heat map 2.0, and then a deployment plan, which is a statewide deployment plan that summarizes based on the modeling work and the lessons from the demonstration sites and sort of all the best practices that we've gathered across the years. That's all going to culminate into this deployment plan at the end of next year. So a lot more deliverables, a lot more work for the eTruck team in 2025. And then I think I'm passing it on to, is this Liz?
Yes, thank you, Ken. Great. So moving on to, we wanted to present the workforce development mapping tool that we are currently developing and kind of gaining some kind of insights and feedback from TAC members here on this tool. So if we just go to the next slide. So to give context as to why we are developing this tool and the purpose of the map in the context of workforce development for the eTruck project. So this is following feedback from our Workforce Development Advisory Committee. The team set to answer 2 questions from this committee. So the first one was, how can the eTruck project identify where current and future training needs will be in California? And then secondly, how can we make sure that local communities kind of have access to the training and are able to kind of gain access to these local jobs that will be created as part of the medium and heavy duty charging infrastructure network that we are anticipating for 2030 up until 2040. And so this brings us really to the kind of overall goal of this map here that we can see on the right-hand side, which is to amplify the positive economic effects of building and deploying these charging infrastructure sites in these communities. So what we found also, especially with conversations, for example, with communities in the Inland Empire, is that the economic positive effects of these stations speak louder in some ways than the environmental positive effects of having these stations in these local communities. And so there really is an emphasis here in supporting a localized workforce in these communities. And so making sure that we are filling the training gaps in these local communities to kind of allow these communities to gain access to the jobs that will be created in their area. And so I will be going into a little bit more detail on how the tool will be developed in the next few slides, but to give an overview, we're using the modeling kind of results that we're getting out of the eTruck project and kind of converting those metrics, for example, number of chargers into kind of number of jobs that will be created in different categories using the methodology that has been developed by the International Council on Clean Transportation with a report that came out this year, and also kind of conducting interviews and doing research on the current training programs that are available for zero emission kind of vehicle training in California. And in terms of how we anticipate this tool being used as part of the eTruck project and beyond, the first one really is to be able to kind of give information or visual for example, community colleges or training centers and local agencies to be able to plan where training will be needed in their locality based on the anticipated charging infrastructure needs. And secondly, this will provide a visual tool for the community-based organizations that we're working with as part of the eTruck project to be able to kind of look into specific localities and the kind of training needed in those localities as a way for them to advocate for training center opportunities in the area. So if we move on to the next slide, in terms of how we are developing this tool, the first step here really is to identify where the future workforce needs for medium and heavy duty charging infrastructure will be located in California. And so here we're leveraging the modeling activities within the eTruck project. And some of the key metrics here that is needed are the number of chargers and power levels. At this point in time, we're looking at a 2 to 10 mile radius for this information. And then we need to be able to translate number of chargers into the number of infrastructure jobs that are needed by different sectors in California. And again, here we're using kind of the baseline assumptions that have been presented by the ICCT in their recent report. I'll go into a little bit more detail on this methodology in the next slide. And so once we have this kind of initial information, we can then overlay this information by, in the first instance, identifying where the current training centers or opportunities are in California, and then where they will be needed by 2030, 2035, and 2040, based on the kind of future workforce needs identified in step one. And then it's a question of overlaying all of this information into the mapping tool. So I'm just going to go quickly here, just in the sake of time. So if we just move on to the next slide. So here, this is a screenshot from kind of the kind of job projection tool that has been created by the ICCT. So this is a report that came out this year in 2024 called Charging Up America. So as you can see here, they've identified the job types and job categories that we will be using for our workforce development mapping tool. So here they've kind of we're naming these skilled labor jobs. So we're looking at, electrical installation of the chargers, but then also the maintenance and repair of these chargers, the charger assembly, and then the construction labor to build and develop the charging sites. And in terms of office-based jobs, we're looking at software maintenance and repair, planning and design of the sites, and then the overall administration and legal jobs that are needed to build this charging infrastructure network. And maybe to go into a little bit into the methodology as to how they came up with these numbers that we're seeing here. So the baseline information is being able to calculate how many person days are needed to add one additional charger to a charging site. So for example, one additional, let's say 150 kilowatt charger at a site would necessitate 4 person days of electrical installation. So one singular person would have to work 4 days to install this charger, and then they will have a different number again for electrical maintenance and repair, let's say 2 person days. And so what we're seeing here is an aggregation of these person days into the equivalent of a full-time job at a national level. And so if we move on to the next slide. So this is an example of the information that we are also collecting in step 2, which is identifying the current training programs in California. So I've listed here a few of the kind of main categories that we are monitoring. So for example, community college programs, I think, are of special interest to us just because they are very localized and also flexible and open to adding new training programs, for example. But then we're also looking at specific skilled labor programs needed for the workforce development of medium and heavy duty charging infrastructure, such as electrical, construction, and then utility specific programs. And then kind of an overview of the university research centers focused on medium and heavy duty charging infrastructure. And so here we've given a few examples of the kind of LA County programs that are currently available, such as the Electrical Training Institute, the East LA Skills Center, and Caltech also has a few programs there focused on medium and heavy duty infrastructure training. And if we go on to the next slide, thank you, Gia. This is, again, this is just a draft. We're still kind of developing the tool. So this is an example of kind of how the tool may look like. So again, I just want to reiterate, we do not yet have the modeling results statewide. So what we've done here is that we've just used the charger counts by kind of charger power levels from the AB 2127 assessment, which kind of give us county level numbers. So this is, for example, the LA County. And so we're able to calculate kind of person days, as I mentioned previously from the ICCT methodology, which translates into kind of full-time worker equivalents there that we can see at the bottom of this table, so 2,370. And then the next step was to identify out of these job categories which ones were considered as local jobs, right? Because this is kind of the main goal of this tool, really is to make sure that kind of training centers are available for the local communities to be able to kind of gain access to the jobs created nearby. And so here we've highlighted in blue the categories that, you know, based on the interviews we've been having of infrastructure developers and based on our research, are considered local jobs. So if we just go to the next slide, this is just a kind of an overview, if we're just looking at county level results, of where current training programs are available and where kind of current forecasts for 2030 are predicting kind of main counties that will be needing workforce development training. As we can see, there's a kind of a corridor starting to appear there between San Francisco, Los Angeles, and San Diego, and a kind of a heavy need in Southern California. Can we go to the next slide, please? All right, so for the sake of time, I think we only probably have around 5 to 10 minutes for kind of the discussion part of this. So I'll just open the floor here to TAC members, maybe initial feedback on what was presented. And then we have some specific questions and challenges that we're working through at this point in time. Maybe I'll just highlight a couple challenges we're working through. One of them being kind of distinguishing between existing developments and kind of brownfield sites, and then versus starting a site from scratch, right? And kind of how does that impact the workforce needed at that particular site, and how do we calculate this? And the second challenge here is kind of distinguishing between lower powered chargers. So here we're looking at 150 to 350, and then kind of higher powered chargers, 1 megawatt and above. And how does this impact the workforce development or work or labor needed at those locations? So I'll just pause here and open the floor to questions or feedback. Lila, I see your hand up.
There we go. Just had a quick question. I was wondering if you know if the folks who are doing this analysis have connected at all with Long Beach City College or LBCC. I mean, we work with them quite a bit on doing workforce development assessments, and it comes to zero emission trucks as well as port related equipment. But I know that they have a fair amount of connections through the LBCC Trade Tech in terms of working with different industry, zero emission truck industry sort of folks to do training and whatnot. I just thought that might be a good resource.
Absolutely, yes, that's a great contact. Thank you, Lila. Gia, I think Gia's on the call. She's kind of been leading the outreach efforts with community colleges. Maybe Gia, I don't know if we've contacted the Long Beach City College yet.
Recently we haven't, so I think we should definitely be in touch with them again.
Thanks, Chia. Mary, I see your hand up. Sorry, Mary, I'm not able to hear you.
Can you hear me now?
Yes. Great.
Okay. A quick question. Did ICCT come up with the categories of laborers?
Yes, they did.
Okay. And is it conventional wisdom that medium and heavy duty sites will need site attendants?
So this is based on interviews with infrastructure developers. So this was particularly, I think it would, from memory, it was Terawatt mentioned that they have either 1 or 2 site attendants at each site. Sorry, Mary, I'm not able to hear you.
I don't know why. Try this.
We can hear you now.
Is that better?
Yes.
Okay, great. Okay. No, I just curious as to whether that is something that all uh, all members of this committee think is the way that things will go, that there will be 1 or 2 attendants, and if so, what kind of skills they have. Just are they able to troubleshoot? Are they able to are they plugging things in and plugging things out so that you can maximize that for a reservation system? What is it that the people are doing, and what skill sets do they need to have?
So Mary, I think we need to dig into that, but I think one of the things that we've heard a lot in the truck charging plazas is that there is a need for the truck stop. Like if you notice a lot of these truck travel plazas, like they have everything from showers to buying food and a whole bunch of amenities, so I think what we're trying to dig through, and it's something that I've asked Liz a little bit more about, is are these like there's going to be site people that have to work on the site to provide the amenities, but we're trying to dig through whether those are like the attendants, which is where you went to, where somebody's like helping to plug in and unplug the vehicles versus supporting these sites with other amenities.
Yeah, just curious, since we're going to be working on these projects, I'm just not sure that we had we aren't at the place yet where we've conceived of needing staff, full-time staff, but it sounds like no matter what, there needs to be some sort of full-time staff at all the medium and heavy duty sites.
Yeah, John, I see your hand raised.
Yeah, just on this thread with Mary, I think just putting it in real terms, when you look at firms like Green Lane or Travel Centers of America or Loves, who have like a truck stop oriented business model where there's a significant amount of mixed services and amenities, Mary, an attendee will likely be present or multiple attendees to provide various different amenity services. Whether or not those attendees will have on-site technical support roles, I think is kind of TBD, and it will depend on the site itself. I think in many instances, what we're seeing now is if there are technical issues at an EV charging site, the person who needs to fix that issue needs to be called in versus being there stationed physically, for an 8 to 10 hour shift. Whether that remains to be the case, I'm not sure. But I think to get at your question, it's kind of dependent. It's site specific, as most things are. And it's also dependent on whether you're talking about something that's, a depot based or subscription based model, or something that's purely public. And I think if there's something like that's purely public, right, like looking at forum mobility and that has a subscription model, but really any truck could potentially pull up in there and charge. The sites that they've developed don't have like a building where somebody sits at a desk and waits for there to be an issue. It's kind of like you go in, you tap your fob, you plug in your truck, you tap your fob, it starts charging, similar to the experience that you and I would have with our passenger EVs. So I think we'll see a mix, right, of the skills that are required for attendees, and it will largely be determined on what services are located at that particular facility. I hope that gets at your question, Mary, but that's kind of what I thought you were asking.
Yeah, absolutely. Just it looks like there are ratios here, and I just figured there was something that went into that, and that I may be unfamiliar with. But thank you.
Christy, I see your hand up.
Yes, hi, Christy Villarreal from the CEC. Just to kind of tag on to that response to Mary, right now where we have a medium heavy duty solicitation, critical paths 2.0, that's out right now, and we're accepting applications through January 15th. We're considering extending that. We're not sure yet, but for the way the manual is, well, the way the solicitation is structured is that the stations need to be publicly accessible 24/7. And given that, if you think about also maybe even the risk to the security of the infrastructure, I think that so far from Critical Paths 1.0, those that we've funded have been 24/7 attendance, but this is for public infrastructure. So yeah, and I didn't realize that Forum had that model where they could anyone could drive up and charge. I mean, how does that work with the security, keeping the infrastructure, I guess, secure? Does anyone know? Okay, I just wanted to ask on that follow-up question. But yeah, that's the model that we're currently using. But there's not one size fits all for sure. But yeah, if it's a 24/7 open to the public, it seems like most of the developers are using the full-time or on-site attendees all the time.
Thank you. I think for the sake of time, Watson, should we move on to the next topic of conversation?
That'd be great. Is my audio coming through clear?
Yes.
All right, perfect. Great. So on the next slide, we have just a little background on the phase 2 part of this project. We have the parts that we've been talking with you about during this project are the phase 1 part of the project, and we develop a plan for a statewide plan. And if you can jump to the next slide, that would be great. Perfect. Thanks. And so the opportunity when we receive funding is we got funding for phase 1 portion of this project, and there's a phase 2 that was available to us during the solicitation, and the opportunity exists for us to the funding that was set aside for phase 2 was $10 million with a 50-50 match. The CC's asking if we're going to pursue that to get some proposals to them in early 2025, so that it can kind of be go through the process of being reviewed and agreed upon. So the targeted area that we're aiming for, that was identified in the solicitation, is, I won't read the words here. We can all read the innovations of pre-commercial technologies. But it's trying to identify those things that are going to make a difference to this industry, have an impact, and what are those these emerging challenges that will have an impact. And so when we start thinking about what are the things that have an impact, on the next slide, John and mentioned this earlier, about the flexible interconnections, and so I'm going to go through something, a little different way to explain what that problem is, because again, we want to have an impact, and so in order to have an impact, we want to understand what the problem is so that we can put together a proposal and a set of actions and things like that will address these issues. And so I'm going to use this slide as a way to describe what the problem is. And the utility grid is a system. When we look at system-wide planning for EVs, like the utility grid's, pretty well positioned. We're generally not like, in crisis mode around building new power plants to serve EV charging, and the light duty EV charging infrastructure has I'm not saying it's been perfect, but we've been able to address a lot of those challenges. And what the challenge is that we've seen with the medium heavy duty trucks and the infrastructure for these bigger vehicle charging, it is, I'll call it kind of a matching problem. I don't know if that's like scientific term for what this is, but it's kind of a bit of a matching problem, which is, as you see in this graph that's here, we did a survey of electric utilities that said, hey, if a customer comes to you with this kind of load, this is a nationwide survey, it wasn't California specific. If a customer comes with you with these different loads from 1 to 20 megawatts, what's the likelihood that you're going to have upgrades? And what you see is, you go to these higher power levels, it's more likely, and it's just the physics of things. It's just the natural physics of the capabilities of wires and things like that. That as you go up in power levels, the more likely upgrades are going to be required. And so I have some examples of what those things are here. But why I say this is a matching problem, and how did this flexible interconnections kind of notion come into play here, is a couple things happen from the utility side, and a thing happens from the customer side here. And so when you look at the utility side, they take the most conservative approach to understanding whether an upgrade is required. And they say, is there, on the worst day, the hottest day of the, of the year, that during a singular hour, can they serve the power loads of a quote 5 megawatt customer? And they look at it based on this worst case scenario kind of planning. And so what that means then is that they're going to have a very conservative reaction to whether upgrades are required. And then also at the customer side, the customers, like, like John was asking about the MHX site, they're going to also have their own version of a conservative approach. And John was asking, at the MHX site, there's going to be 4 350 kW chargers. So if you just multiply that, the customer may ask for 1.4 megawatts. But the reality is that there's only going to be 200 kW charging going on there at each of those charging spots, and with those power cabinets. So that takes you down to a power level that's probably half of what people sometimes call nameplate. And so the notion of what a flexible interconnection is how do you find that middle ground between those two extreme solutions so that there is a solution that can be delivered faster to the customer at less cost and satisfy the needs of those. So that's the philosophy of these flexible interconnections, is to find that middle ground. So that there's a defined criteria that says during those 10 hours a year that certain grid conditions are occurring, the utility may provide a signal to the load or some other mechanism to signal to these EV customers that they just have to mitigate the load at those hours. And then it's more how do customers understand what's actually the requirement that they need based on the actual usage that's going to happen, not sizing it for that extreme example there. So that's really the essence of what a flexible interconnection is. I'll pause there for questions before I jump onto the next slide there. Any questions about this? Great. So on the next slide, we start laying out what our initial thinking is on this how we can get this increased flexibility from both the customer and the utility side to get solutions that are can be delivered faster, cheaper for customers that are in this kind of category where you're reaching situations where you're forcing grid upgrades based on the size of these loads. So the topics we're driving towards is this flexible interconnection. Some people call it, like in the SCE pipe, the load control management system approach, and the virtual power plants, and how can even on that same distribution level circuit, can other resources on that distribution circuit be used to provide that so-called flexibility that you aim for. And again, so the benefits I kind of mentioned of mitigating grid impacts, improving energization timelines. But there's a lot of challenges to implementing these things, and so the work that we're talking about to understand the challenges, help bring forth solutions, and again, at the end of the day, have an impact on this thing, is we've identified some task areas here. Around task one in what we're thinking is to doing a technology and maturity assessment. It modeled a lot on how we did the phase one of eTruck, which is, doing surveys, interviewing technology providers, understanding what the state of the art is of technology in a systematic way, talking with the utilities, understanding what their needs are, in order to implement these kind of approaches, doing a literature review, understanding where the gaps are, whether it be from the technology side or practices or standards that are pursued. So that would be the one set of tasks that we're starting to frame out in this. Second area would be identifying a roadmap. What are the key enablers and starting to bring forward tools. So it's not just like having a report that says this is the way to do it, but it's what are the tools that need to be in place to make that a viable solution that can be implemented. And so we're whether that be through some kind of vetted approved product list for these management solutions or other validation frameworks, we want to look through and start to develop the starting point of what those tools are. And then part three of this would be a demonstration sites where we implement some approaches that were identified early in this viable situation and do the measurement and validation at those locations. I don't know, Yasi, you want to hop in on anything here on
you're doing a great job. No,
okay.
I just would emphasize the main purpose is sort of digging deeper into understanding where can we move interconnects faster. So that's sort of one of the main reasons of the flexible interconnect. Where can this happen at a faster rate because the market needs it? And with the virtual power plants, again, looking at, what other battery storage or what other distributed energy, as well as sort of a more integrated approach between the load and the power source happens so that we have a more connected system overall. And we're sort of reaching out to you guys as our technology advisory committee here to get feedback, comments on this. And I think we have some next steps in terms of what some kind of ideal sites would be that we welcome feedback as well.
Yeah. So you'll get these slides and I was going to skip forward to the discussion slide. Perfect. If you could skip ahead there. Yeah, you'll have these slides. So again, one of the things that as Yasna mentioned, we'd love to have feedback on the topics we're looking at and the approach that we're pursuing. But also, if you notice, a big part of this would be having demonstration sites, and so we'd want to make this. We'd want to get towards a fast implementation of these demonstration sites. So we're going to be, use a overused term. We kind of want to be identifying these quote shovel ready kind of projects that we'd be able to implement these solutions in, and so we'd love to have some suggestions on this also in this area of like how can we like find these quote shovel ready projects. Like do we have suggestions of who those might be? Do we have any hand raisers for these kind of demonstration sites? So that we want to be able to be quick and responsive, because this is kind of an urgent and important issue, and we kind of want to start pursuing this pathway and get activities going fast. So I see Catherine, you have your hand raised.
Yes, I just wanted to mention, I know the Port of Oakland is looking at doing some truck charging on sites near the port. Um, I forgot who the contact who's working on that. But yeah, definitely look at contacting the Port Authority.
Okay. No, that's
Yeah, I
great.
think Forum Mobility was gonna be in that one, but yeah, we're in touch with Port of Oakland, and I think we have Port of Oakland Tim on the call.
Hi, good morning, everyone. Since you mentioned us by name, yeah, I was just thinking
Sorry,
about
Tim.
no worries, no worries. The forum site is a possibility
Okay.
here. It's an interesting one because we are that immediate utility provider for forum. But that being said, right above our substation, it's a PG&E service, and so we have any number of different interconnects, any number of different discussions that are needing to take place and have taken place to make sure that first and foremost, Forum has the power, but then moving up the chain, PG&E can ultimately supply at the distribution, the higher level distribution. And so that might be a decent case study for something like this. They are putting in their permits, so we should be beginning construction at that site sometime sooner. At least they should be. So we should probably talk more offline when we have a moment here.
Yeah, great. Great, but we were also thinking, I see Jimmy, your hand, and John, your hand, and somebody else. We were also thinking of some of the federal funded projects that came from charging and fueling infrastructure or TCEP or Super Truck Charge, which is in the works. Just some ideas that we're throwing out. Jimmy, did you want to speak up?
Yeah, this is great to hear. The number of projects that I think would all benefit from this element being included. The I guess rule of thumb, federal funds are have the least flexibility in general. If actual funding was needed, once we get into contracting and whatnot, I mean CFI we haven't finalized. We're finalizing our grant agreement with FHWA right now. So hope to have a solicitation out in California and the other Oregon, Washington, 2025 sometime, very TBD. So if a project were to come in like from the get-go with that as an element included, that would be, I think, a very easy and great, aspect of a project. Other projects though that are already in the works, I would say like in the state side in California, there might be flexibility to include those elements for projects that already have been funded. Like I'm thinking TCEP, the BP Pulse sites that were funded under Cycle 3 with TCEP. Generally, a little bit more flexibility with state funds.
Great. Yeah, and you hit the nail on the head. Funding is needed. Watson didn't exactly get into funding on this, but we have on all of the project with CEC, we have a 50-50 cost share actually. So that's sort of the direction we're going in. John,
Hey, John.
unless you have Watson anything to add or Jimmy.
Go for it, John.
Yeah, I know we're at time, but just on this topic, I do think generally speaking, there's value here. And agree with Jimmy that there may be opportunities to leverage either existing awards that have been made that have, grid management requirements, whether it be with DOT or EPA funds. I know for our Clean Ports program and for our Clean Heavy Duty program, we weren't able to fund any upgrades in front of the meter. So everything we do is kind of at the meter and then closer. So panel upgrades, switchgear, battery storage, but anything that's distribution level, none of our funds are touching via our investments under Clean Ports and Clean Heavy Duty. So there may be an opportunity for utility and or state partnerships for those aspects, like at some of the larger port installations. So to be continued on that one, and we'll have to see how those projects play out. But the thing I wanted to highlight here, as I was looking through Watson's slides and thinking about other work that's going on at CEC, I had a briefing from Sean Dory at CEC recently from CEC's R&D branch, and they actually have active projects in this space right now that were funded by Epic starting in 2021 to demonstrate how solar storage, managed charging, and other DER strategies can offer benefits for medium and heavy duty plug-in electric vehicle electrification. And they have 5 active projects right now in the state of California, one with WattEV, one with Cisco, one with Travel Centers of America, one with Mo EV, and one with LBNL. And they're all set to conclude around the 2026 timeframe. So Sean Dory is the principal investigator, project manager at CEC, and I'm sure folks who are here from CEC can put you in touch with him. But it was a really interesting set of remarks that he had, and certainly very timely work, and some that I think could probably be leveraged for the literature review element of what you articulated, Watson, kind of just taking stock of where CEC and its funding partners are in developing those strategies. And I think the upshot of it for me is obviously somebody who wants to ensure environmental benefit from these investments. It's to the extent we can, utilizing non-combustion on-site energization alternatives. That's certainly, in our view at EPA, is a suboptimal resolution to grid interconnection delays. We don't want the absence of energization to lead to more combustion and human exposure to exhaust emissions. Zero emission vehicles are intended to eliminate that human health impact. So if as a result of grid delays, we're just creating new sources of combustion and human exposure to their exhaust, we're not getting to where we need to be by making sizable capital investments in solutions that should be guaranteeing environmental improvement both for human health and for climate action. So just wanted to part with that last remark.
We totally agree. We support that, John.
Very good. Very good. Good discussion. Nate, you want to drive us home here to wrap it up?
Yeah, sure. I'll close this out. So just next steps, our next TAC meeting will be about half a year from now. So mid 2025, June 24th, which is a Tuesday. Any additional feedback, feel free to send to me and Fernandez at calstart.org, and be on the lookout for our follow-up email, which will include the summary of this meeting and the slides for you to check out.
Yeah.
And the recording.
And it does sound like, Nate, we're going to have some follow-on conversations about these demonstration sites in this phase 2. So
yeah, we may have a subcommittee meeting or breakout session.
Or such. Right.
Yeah. Okay.
But yeah, thanks for staying a little bit over, and thanks for the lively discussion. It's super helpful in guiding the project, and hope you all have a good rest of your week. Take care.
Great. Thanks.
Thank you.